Hey everyone, good morning and welcome to our USEA consensus briefing on carbon management and energy transition projects and economic opportunity for Kansas. We have Eugene Holubniak here, a CCUS program lead with the Kansas Geological Survey, and he has a presentation for us today. But first, a little bit about myself and USEA. I'm Michelle Littlefield. I'm a program coordinator with the United States Energy Association's Consensus Program. Just a little bit about us. We are formally named Building Consensus on Carbon Capture, Utilization, and Storage. We call this Consensus for short. This is a cooperative agreement with the Department of Energy, Fossil Energy, and Carbon Management. The program seeks to educate the public, policymakers, industry, and stakeholders on CCUS and carbon management technologies by hosting webinars, monthly educational briefing series just like this, conference workshops, technical reports, and we have bi-monthly news clips of CCUS and carbon management updates. If you want to be on our mailing list, please shoot me an email at the bottom of your screen. At the end of the session, we will have a question and answer portion. Please use the Q&A box at the bottom of your screen to submit a question, and we'll address as many as we can. So this webinar will also be recorded and posted on our event page along with all of our others, as well as the presentation slides if you would like to take a look at those. But we do really appreciate you joining us live. So with that, I'll pass it on to Eugene. Thank you very much for being here.
Thank you, Michelle. Thank you for the introduction, and thank you for the opportunity to present my talk today about Kansas. Well, let me share my screen. I'll do it in a second.
There we go.
All right. So let me present our team here at KGS, that the group that is involved in CCUS. And we have long-standing members and also new joining us. Also, please look at our participants in at least latest projects, and also most of our CCUS activities, at least so far, were funded by Department of Energy and ETL. So please welcome my co-authors, Frane Kashuk, Jenny Meng, Stefan Borny, Diana Ortega, Doug Lewis, Jen Rainey, Ibu Kunbade, Sahar Mohammadi, and George Sofles. Well, I'll start from, with a little excursus in history. It used to be that Kansas was developing very rapidly at the beginning of the 19th century, end of beginning of 20th century, end of 19th century. And El Dorado oil field, one of the major fields that was contributing to the World War I effort. And some of the counties in Kansas were growing at a very rapid pace, doubling in population in a matter of several years. And at that point in time, it was a big deal. And with the new oil discoveries, Kansas was prospering and going. The economic growth was pretty quick. I usually show the slides which show the CO2 potential, but one of the curves on this slide shows the oil production, and that the Kansas oil production is falling. And at the moment, it doesn't seem to be that this curve will recover anytime soon. And probably the only technology that comes to mind, at least so far, is the CO2 but even CO2 I'm not sure if it can bring the previous growth to Kansas. And so, in my mind, and in what Kansas Geological Survey think, some of my colleagues at Kansas Geological Survey think, is that the energy transition projects are, in fact, could be at least one of the directions where Kansas can go and where Kansas can grow its economy. And the history of energy production is also evolving. And so now we have Kansas electricity generation being produced from, a lot of that being produced from both the fossil fuels, but the renewable sector is growing very rapidly. And so this new sector is actually conquering the large part of the economy. Right now, it's sometimes up to 75% of electricity could be generated for wind. It depends on the time of the cycle, the seasoning, and so on and so forth. But the truth of the matter is that there is change in energy production in our state. And so what Kansas Geological Survey does, we're a research unit, and we are serving the public under the umbrella of University of Kansas. We are quite an old organization, for at least for United States standards. We're 132 years young. We have about 100 employees, and out of those 100 employees, about 30 are scientists, depending on, again, when we're speaking. We also have a lot of data resources and services that we could provide. And we are doing the research that is specifically relevant to Kansas. So basically, we're tasked to help to identify and to facilitate the resource development, including water, but also energy and other potential resources. And so why do we care about CCUS in Kansas in general? Is that there are large point sources of CO2, and again, with this rapid development of renewables and the energy transition that is currently happening, we'd like to keep those large point sources of CO2 continue generating electricity, at least for some time, because of the investment in these facilities is expensive, and we would like to keep it for as long as possible, but as sustainable as possible. And we also have a lot of resources that are readily available for CCUS projects, but other energy transition projects as well. And we also have mature oil and gas industry that could actually help to facilitate this this transition, because oil and gas industry knows about how to develop projects like CCS projects and others that are relevant to the energy transition. We also have the history of injecting different types of fluid in the subsurface. And this also, as you will see from the presentation, could be good and bad. But we do have this experience, and it would be a waste to throw it just away. And this is Evergy's Lawrence Energy Center. And this is a coal-fired power plant that will be decommissioned in the next couple of years. In my mind, at least, it could be retrofitted with some other technology. You could probably install maybe a hydrogen generation facility instead. But then the question comes to mind: what about the infrastructure? What about offsetting the excess energy production in the form of hydrogen? How do we deal with that? But also, if you are producing hydrogen, you still, and especially if you're not producing it through the green way, but the blue, where we're using natural gas or other fossil fuels to generate hydrogen, there's going to be a CO2 stream that will have to be considered in the cycle, and you have to get rid of CO2 as well. So you need to think ahead when you're trying to facilitate this kind of change. So this is not to brag, but basically kind of outline the projects that Kansas Geological Survey has been working on over the years, and this history goes back more than to early 2000s. But we have worked on a number of CCUS studies, CCS studies, including the carbon safe program, and also we're currently involved in a carbon utilization storage partnership with the DOE, and we're with CUSP, one of the members of CUSP. And so, to begin the story for carbon management, one of the key areas, and this is what survey does, is of course the geologic storage. In order to set the stage, we need to understand if Kansas is a suitable place to park your CO2. And looking at the maps, and these are just basic geologic maps that show that yes, in fact, Kansas is actually a reasonably good place to park the CO2. First of all, the depth to the depth of the reservoirs is reasonable to store the CO2 in supercritical condition. As you can see from a graph on your left top, in the left top corner, this is the depth and feed below ground to the top of the Arbuckle. And from this graph, it is clear that only eastern part of the state is not suitable for the CCS projects, but the western part of the state is definitely enough. There's enough depth to store, and not only in the Arbuckle, but also in the strata that it's overlaying the Arbuckle reservoir. Also, you can see that the maximum allowable increase in pore pressure is also suitable for storage. You have a lot of headroom to squeeze enough CO2. In fact, a lot of reservoirs in Kansas are under pressure, especially if you go to western part of the state. Also, in terms of salinity, at least this is for Arbuckle, but the similar maps are for other formations of interest, such as Lansing, Kansas City, Wyola, Osage, Mississippian age formations are similar in the distributions, but again, as you can see, western part of the state looks, western and southern part of the state looks a lot more salty, so you do have that consideration. But also, you know, due to recent developments and due to our experience in handling the sort of the effects of development of the shale plays, let me say unconventional plays in Kansas and Oklahoma, we need to consider the basement and how faulted the structure is, how is it connected to the basement, are there faults that could go off. And we do have a few areas that are of interest. One of them is a mid-continent rift in eastern part of the state that runs basically from Minnesota to all the way to Oklahoma. And then you have the uplift in central north central Kansas, next to the Salina Basin. So considering all of this, it seems like one of the best places to go to store CO2, at least one of the obvious places, is western Kansas. And as you can see, you will see from the subsequent slides, is that it is probably the most logical solution to go to the western part of the state. Also, in terms of the experience, Kansas Geological Survey has run a number of projects. Some of them were as early as 2005, where we did a little CO2 pilot in Halgurney field that's next to central Kansas uplift in the central part of the state. So at that time, very sophisticated modeling has been developed, but the project is kind of considered to be kind of marginally successful, but what we have learned from this project, the main part from this project is that CO2 can be injected for CO2 and you can recover oil, and the oil recovery is actually it gives great results. But the only problem with this is that the containment of CO2, and likely you will need, instead of doing the small pilot scale project, you need to flood the entire field, and that would be more efficient and better controlled activity. Also, we had just purely scientific endeavors, just looking into how our carbonates basically look like. One of those projects that Jason Rush from now is with Oxy has led is that the horizontal drilling through one of the karst in at Bemis-Schutt's field, and this is one of the typical examples of the oil and gas play in central, next to central Kansas uplift. And now, because of this project, now we know how those carbonates look like. We did extensively study both the seismic. We did the reprocessed seismic to find out about the palette karst, and we also drill, because we could drill the horizontal well, we could also match the imaging logs with the features that we see on seismic, on 3D seismic. We also had completed a large scale regional studies looking into Arbuckle, but also other formations. From here, you can see that there's a number of wells that we collected and put into the database, processed all this, and created a number of models. We did the simulations for about 10 sites across Kansas, looking into the storage potential. Now we know that though, at least in those initial simulations, we could say that it is safe to say that south central Kansas, southwestern Kansas can store beyond 4 billion tons of CO2. So this capacity study has been done, and so now we're confident about going into the next stage, into more kind of commercial scale development. We also had this Wellington EOR, and also the attempt for the USC Class 6 project. And one of the takeaways from this was that yes, you can do CO2 EOR, you can do it safely, you can actually make sure that you have a containment on the reservoir if you gather maybe a little bit more data. And I can go into specifics what kind of data was useful, but we studied this field extensively, and now we understand what to do if you do the CO2 EOR in Kansas. Even on a small scale, you still can be successful. So that project, that part of the project was a success, but then we attempted the Class 6 permit, and that got into a little bit of the it basically didn't continue, although we did cover all the technical issues, but because it was a pilot scale project and not a commercial one, we hit the kind of roadblock, and we couldn't cover for financial responsibility. But in the process, we've learned how to do the Class 6 permit, and how to advise the industry in case they decide to apply for such project with a Class 6 permit. And with the next set of projects, it was a planning and development for the carbon safe phase 2 that we did with Battelle and EERC. It was even greater detail for the data gathering and drilling and well testing and other activities in Western Kansas, where we believe is the most prospective place to store CO2. And so that is even greater detail for the projects. And so we do have even more data and even more confidence about how much CO2 you can store, and where you can go, what kind of formations there are, and so on and so forth. And so here you can see some of those bits and pieces. So we did the background seismicity monitoring because of our previous experience, and I'll go into more detail about this challenge for the industry and also for the mid-continent in general. We also did a lot of modeling and simulations for this particular play, and now we understand again that just one structure like this can hold more than 200 million tons of CO2, and you can do it over a reasonable period of time. So in 25 years or so, you can squeeze more than 200 million tons of CO2 into this just one structure like this. And we did recover the seismic. About 26 square miles of seismic were gathered at that location, and we understand again how these forms play. And it is interesting even from a fundamental standpoint, from the what kind of structures there are in this part of the state, and structure like this, Patterson, Heinitz, and Hartland. There's also rope like this. There's a number of very similar structures, and they can hold very similar amounts of CO2 based on our estimations. So detailed geological models were built, and detailed simulations were created to back up our estimates for the capacity. And also what we could see in the Western Kansas, and again why we are suggesting that the western part of the state is a better place to store CO2, especially if you're talking about a large-scale, commercial-scale project where you store millions and millions of tons of CO2. Is the fact that we do have a stacked storage complex where we have several formations. In this case, it is Osage, Viola, and Arbuckle, in which you can actually safely store CO2. There's enough pore space. There's enough permeability to squeeze the CO2. And if you want to have a large-scale hub type of project, you'd better do it in the western part of the state. Why do we need the stacked complex? To name it, one reason is to make sure that your project is not stopped due to risk management issues where you have for example, induced seismicity, and you try to understand where the seismicity is coming from, where it's most likely coming from from the interface between the basement and the overlaying formation, and so you can abandon that formation that touches the basement and go into the isolated complexes above you, so that creates a kind of risk management tool for your project to proceed. We also know a thing or two about the CO2 sources and economics of these sources, and I realize that this data is probably right now even dated, but at least we understand how to scale the sources, why they're so complex, why the price forming for the CO2 capture is also complex, and why it's not just one number. Thanks to our partner Lindy, who did an amazing job looking into those feed studies for the number of facilities, including 2 power plants and 1 refinery. We understand it's not a simple answer, so there couldn't be just one quote for the CO2 capture price. It depends on the case. It depends on how you design the facility. It depends on the design of the facility itself. And so in this complex issue needs to be attacked, on side-by-side case. And the studies like that are necessary if we want to progress with CCUS projects and make sure that they're actually making it to a commercial scale level. And also, if we are looking into this option where the Western Kansas is the best candidate, and again, with that, I'm not saying that you might have a smaller scale project in other parts of the state, and I know for a fact there's a number of ethanol plants that are currently discussing the potential to store the CO2 just right underneath the locations. And again, in this case, it is most likely going to work because of the amount of CO2. Those plants are storing anywhere from 2 million tons to I don't know, maybe 10 million tons over a lifespan of the facility, and who knows how far this lifespan is stretching. But just in general, this amount of CO2 is not large, and so yeah, you can park it on just right underneath your facility or somewhere in the vicinity. But actually, some of those ethanol plants are finding out that you sometimes still can't store the CO2 right underneath, and so you need to actually build a pipeline at least a few miles away from your plants to get to more favorable in terms of geology, in terms of land ownership and other issues. So in a lot of cases, you still need to build some sort of pipeline to get away from the plant. But if you are talking about large scale sources, but also if you are talking about bringing maybe some of the CO2 from the outside, and you might need to, especially in places like Iowa and Nebraska, where the CO2 storage potential is, where geology is not as generous, let me say, as in Kansas, you might need to bring a pipeline, and you might stretch your pipeline all the way to Texas, maybe, or to Oklahoma, to basically share it with the other CCS projects or CCUS projects like UR projects, maybe. But part of that CO2 will hopefully stay in Kansas, and this is basically why we think about why we think ahead, and why we think that the pipeline structure is necessary in our state. And in general, if you do have a large point source like Jeffrey Energy Center of Evergys, and you have about 12 million tons of CO2 generated per year, you are no longer have an option to store the CO2 right underneath you, and so you need to bring it to the Pleasant Prairie oil field or the Pleasant Prairie CCS structure, or to some other site in western Kansas for storage. And so with that, we have formed this kind of cartoonish looking map, but it gives you kind of basic understanding and basic idea of where your sources and where your sinks are. And so you have your power plants, mostly all of them are concentrating in the eastern part of the state, and you have large point sinks in the western part of the state. So you obviously need that connection, but you also have a fair amount of sources like refineries and ammonia generating basically fertilizer plants that also need to handle their CO2 as well, along with ethanol plants. And so there are also some cement plants and some other sources that are not even on the map, but as we go forward, we understand that there are more to it, and there are more sources that need their CO2 to be gathered and stored somewhere. And as the industry progresses, hopefully this is what is going to happen. At the same time, are all of those point sources can store the CO2 right underneath this facility? Probably not, and so the issue of the infrastructure is even greater in this. And looking at the work that Great Plains Institute has produced, and Elizabeth Abramson from Great Plains and the rest of the team, also with CCS people and with others, they did a great job about outlining, both the infrastructure needs and possibilities, but also where the facilities are, and also kind of stepping away from the Kansas and looking at Kansas in perspective. You can clearly see that there are potential for putting the pipelines through Kansas, and with that, if you do have that kind of potential, and you do have resources, geologic resources to store CO2, to do the CCUS part, the next question is that there is probably a possibility for the Kansas to become a hub for CCUS, where you can actually park or handle CO2. And as you can see, for even more in the presentation, there are other resources that are available that could help in this energy transition issue. So going to the next kind of lessons learned part of the presentation, and I hope from the previous part you could see that there are resources in Kansas, and Kansas is certainly kind of centrally located geographically and also resource-wise to become heartland and hub for CCS infrastructure. But with that, we have lessons to to process the challenges that kind of lay ahead, and one of them is UIC Class 6 permit. And now we understand how to do it. We understand what kind of documents form the permit, and how we can process it, and how we can advise the industry to go forward with that. We also understand that this process maybe could be streamlined a little bit, and hopefully there are ways to do it. But also there's a need for Class 6 primacy for the state of Kansas, and hopefully one day we'll have that legislation that basically sets the primacy for Class 6 in the state of Kansas. Also, we understand that how to manage risks and how to develop a response plan if something goes wrong, but we also are confident that all of the risks that are associated with the Class 6 permitting are manageable and could be overcome. Also, through the projects and through working on the various issues, one of the issues that popped up was the development of the Mississippian line play, and also the kind of neighboring issue where we have in Kansas. And as I mentioned before, we do have a number of wells that inject different kinds of fluids in the subsurface, and there are Class 1 and Class 2 wells. Class 2 wells inject normally things associated with the oil field, and Class 1 wells inject even greater variety of fluids, because it's both the municipal water, hazardous waste, landfills, that kind of runoff can be handled through the Class 1 wells in Kansas. And so you do have large volumes of water entering or fluids entering the subsurface, and with that neighborhood basically issue. And also looking at the locations of those projects, you can see that the western part of the state looks even better in terms of CO2 storage target. And also, as you can see, the increases in pore pressure and static fluid levels also suggest that maybe central Kansas is not ideal for this issue. Earthquakes over time. Here you can see the progression, clear associated with the Mississippian lime play development and the amounts of fluids that went into it. But again, we did learn how to manage this issue. We basically, thanks to that challenge, we now have developed an expertise, and a team led by Dr. George Sofles at KU Geology has developed a set of tools and techniques on how to monitor this seismicity efficiently and also inexpensively as well. And again, we did monitor around the Wellington project, around the Patterson project, and we now understand how the waves are coming. A lot of actual baseline fundamental knowledge is coming from those studies, but it could be also applied towards just a baseline monitoring for the CCUS projects going forward. We also understand the risk assessment part thanks to our Class 6 permit experience, but also through handling those projects. And again, we can advise the projects going forward on this issue. One of the challenging parts, one of the main challenging parts of this is that has been outreach, and that's why I'm very thankful for this opportunity to speak in front of you today. Is actually that part of the education, and yes, we do actually. As a survey, we do a lot of outreach, of course, but it seems like never enough. And so we do have a Heartland USCCS forum that we are doing with the Great Plains Institute, very, very successful conference. We have sometimes over 300 people attending, all talking about different issues, CCUS related. But now also we have a CCUS task force, and we are trying to educate the industry about the need for the legislation. And we're actually trying to do it from even earlier, but due to COVID, we couldn't process the bill that went into the legislation. And Kansas legal and regulatory framework is very necessary, and hopefully we can resolve it in the next year or two. And the main issues are like everywhere else, and it basically comes to the liability issues, ownership, pore space ownership, and also class 2 primacy, but also the eminent domain, especially for the not only for the pore space but also for the pipelines. There's currently not in place in Kansas, and we hope that in the next legislative session it's going to get resolved. So what are the lessons learned from this? What kind of suggestions here? So one is that the Kansas is essentially positioned to become a distribution or hub for the CO2. There is competition for the resource, but it is manageable. There are also alternative resources that I'll talk in a little bit. I just briefly mentioned what are some of the alternatives in Kansas, and also there's always a CO2 option that is available. A source to sink problem, and the nationwide infrastructure is required to make sure that the economy, the CO2 CCUS economy is there. And the state level legislation is also necessary to move forward. So what are the next steps? Some of the things that we would like to look into, and something that we kind of didn't have time or didn't have funding to do it before, but one of them is Salina Basin. And the Salina Basin is a very promising place to store CO2, and the Mississippian system there is not well understood. There are not too many drilling activities, so more research is needed in that area. There are basalts in Kansas, and they're associated, this mid-continent rift probably, and moving all the way from Minnesota into Kansas, and we do have that resource available to develop further. And so again, more research is required, more drilling and understanding of this issue. We also need to understand more about the Precambrian top, and basically the basement research is required, not only because of the CCUS, but also and because of the Arbuckle injection associated issues, but also because of the critical minerals and other issues, maybe because of helium, maybe because of hydrogen and other critical mineral issues here. Also, there's a growing hydrogen infrastructure, at least growing interest in hydrogen infrastructure, and with blue hydrogen, or going forward on even with the green hydrogen, there are possibilities in Kansas to do this. And this is Franek Hashuk's project that looks into the possibility of developing storage, hydrogen and energy storage in salts that exist in Kansas. And as you can see from this map that Franek put together, is that there are wind turbines that if you do have the green hydrogen project, you can potentially handle this fluid through storing it right underneath your turbines in the salts. There are also refineries, also natural gas facilities that can take advantage of this possibility. And there are more salts in Kansas. Basically, there's a lot of resource available, but we don't understand it too well. I think more research in this area needs to be done as well. And there are also critical minerals, and for this area is definitely growing and will be growing in the next several years. And again, this is Franek and Stefan's project on the critical minerals. There's a Cherokee Forest City Basin that tries to develop an infrastructure to both mine those critical minerals, hopefully from the coals in the Cherokee Forest City Basin. But maybe there are other areas where we can look into the critical minerals beyond the coals in eastern part of the state. And so in summary, CCS is rapidly developing, becoming one of the commercially viable technologies thanks to 45Q and other incentives, of course. But if we combine those technologies with energy storage projects, with the critical mineral development projects, maybe there is even a better business case to develop this technology further. So there is also an issue that Kansas is a strategic region. We do have a great geographic position, great resources. There are a number of industries that could be interested in this development, and they're now are becoming interested, and that's why we do have a push to do this legislative changes in Kansas at the moment. So if positioned correctly, Kansas can become a hub, and CCS R&D projects that we performed at KGS and with partners over time help to facilitate this change. And hopefully we can develop our knowledge even better, and we can serve the public better and inform them on the possibilities and how to develop those projects in the next level in the next stage. So with that, thank you very much. I'll take any questions if there are questions. Thank you.
All right. Yeah. Thank you all very, very much. It definitely sounds like Kansas is on its way to combining CCUS and hydrogen to become a big old energy hub. So we don't have any questions yet, but I actually do have one for you. You briefly mentioned rare earth elements and critical minerals. Do you happen to have any other like extraction projects or anything more happening in Kansas about that?
Yes, actually, there's at least at the moment there are just these are just studies, and Kansas Geological Survey, to my knowledge, is heading to two of those projects. One with the USGS and one with the Department of Energy. And one is looking into the Cherokee Basin, and another one is looking into a broader kind of perspective.
Okay. Yeah, we'll look out for that in the future. If you do come across any new projects in CCUS or hydrogen or rare earth elements, feel free to shoot them over to me and I'll put them in the next news clips for sure. So we do have a question from Alex, who is a program coordinator as well with USEA. He asks, how do you expect the new infrastructure bill to affect Kansas?
Well, hopefully we can take advantage of this opportunity, because I think we are centrally positioned for this for this opportunity, and hopefully there is a pipeline that connects basically northern states, including Nebraska and Minnesota and Iowa, and bringing the CO2 all the way through Kansas into Oklahoma and Texas. But also, hopefully, there are some of the other projects that are starting to build in Kansas that will actually try to develop the infrastructure internally, just in the state of Kansas, not trying to go kind of across state. That's kind of what comes to mind, at least from the top of my head.
Sorry about that. Thank you very much for that answer. We do have one message from Mike Moore. He says, please give Doug Luis his regards. He also asks, what is the impact of the fault that runs through El Dorado field in terms of CO2 EOR storage? He understands that the area has a high temperature.
Oh, it is actually a very interesting question, and the faults. What we found is that the faults, it always depends. So it is never clear, how the fault will react, and it depends on just general orientation of the stress and of the stress field, and how this fault is positioned in this field. And so in terms of CCUS projects, and especially looking into this area, it's a central Kansas, it could be tricky to inject. It's not disqualifying, but you need to definitely take a look into the geomechanics and basically verify that this fault is stable under the current conditions. In terms of the geothermal effect, I don't know. I don't have an answer to this question. Sorry.
Can't expect one person to know everything. Yeah, excellent. Well, thank you very much. The presentation and the recording will be available on the event page in either an hour or later this afternoon. Eugene, thank you very much for presenting with us. This has been a a real treat to see the ins and outs of what's going on in Kansas in the CCUS space, as well as the hydrogen space and rare earth elements. Cool to see so many things happening in one place. Oh, we do have one more question from Ben Stewart. Is there any CCUS research being done in relation to increasing the utility of water resources?
Not to my knowledge, not at least in Kansas, but I think this is a very relevant question because of the our difficulties with the Ogallala aquifer in the western part of the state. I'm aware of the projects that do utilize CO2 for water recovery, for example, in China. So maybe with time there is a possibility to actually combine those kind of projects together and do, I don't know, something like critical mineral extraction through solution mining, and then using fresh water produced as a result in some domestic type of uses. But again, it's more research is needed. It's a very interesting problem, and I think more discussion, more research is needed.
Okay. All right. Thank you very much, Ben. Are there any solutions being discussed to reduce source emissions by hydrogasification and bioreactors?
From again, this is my knowledge from discussing it with some of the regulators. There are some of those projects are planned, and some of the storage facilities for these projects are planned. In fact, it seems in different parts of the state. And this is new area, and it is rapidly developing. And again, from even a couple of years ago, that wouldn't be in the discussion probably, but now it is a reality. It's fascinating to see.
Okay. Well, thank you very much, everyone, for submitting your questions. Hopefully we will be able to see you again in maybe 6 months' time or so. If there are any bigger projects or new updates happening in Kansas, we'd love to hear about it. Yeah, I think that's all we have for today. Once again, thank you very much, Eugene, and we'll give everyone a few minutes of their time back. Yeah, thank you very much. Is it all right if I offer, if anyone would like to contact Eugene, feel free to shoot me an email and we can get everyone in contact. No problem.
Thank you, Michelle. Thank you, Alex. Thank you very much.
All right. Take care, everyone. Have a wonderful day.